There we go. We're live. Good. We're doing correlations today. Super important. So now we have two variables instead of just one, and we're seeing if one variable is correlated with the other one. Now, it's not quite a scientific experiment where you have cause and effect. We're just looking to see if two variables are related. There are a couple of things to know, not too much to know though. All we really have to do, we don't have any complicated calculations. We're going to let technology do this most of the time. But we do have to know about R, the correlation coefficient. And we do have to know about the line of best fit and its equation and how to find it. And we're going to use technology. Okay, if you're picking berries and you're paid by the basket, and maybe you get paid to show up because the job is so discouraging, this is a correlation between the baskets picked and the dollars that you earn. It's pretty good. If I drew a line of best fit on that, I could actually get it to go through almost every single point. Look at that. And R would be 1. In other words, that would be a perfect correlation. There's no like berry baskets, difference in price. Oh, sorry, I lost it there. Okay, R is 1. It's good. Notice too that this is positive and R is positive. Okay, this is a perfect correlation, and I could find the linear relationship that would go through that. Okay, this is dollars earned picking berries, and I'm the berry farmer, and we're going to see if I like you or not, okay, and how that relates to dollars earned. So this might not be all that great a correlation. So if I put a line of best fit on there, as you can see, in this case, the berry farmer is just randomly paying people kind of based on how much he likes them, okay? Bad correlation. Positive, you can definitely see it's there. And so this has an R value, and it's going to be somewhere between 0 and 1. It's actually a pretty good correlation. So I'm going to say this is R equals 0.64. Still positive. Okay, phone plan. You have hours of talk and the balance left on your phone plan. Or this could be number of chats in the super chat of YouTube and how much I like you. So notice that your balance goes down as the hours of talk goes up. And not surprisingly, this is a perfect correlation, but it's negative. Okay, it goes down. It's got a negative slope. This would have an R of -1. Being perfectly negative, that's what it's all about. We went to the Spurious Correlations website, and we looked at some correlations that are out there. So we looked at the relationship between the age of Miss America and murder by steam and hot objects. And then we kind of faked the data, because apparently these two are actually correlated, although it's a spurious correlation. In theory, you would expect to see no correlation at all between these two. If there is a correlation, it's random. So this would have, under normal circumstances, an R of 0. So there would be no correlation. I could put a line on there. It wouldn't matter which one. All of them would fit. This has an R of 0. There's a little instruction about how you use Desmos to find the line of best fit. So you enter your data. You can enter it manually. You can actually copy it into a table like magic. You have to specify which data you're using these little subscripts. Now, apparently I go through a big song and dance in the video about using an underscore to make it a subscript, but you can actually just type Y1 now. Desmos has come a long way. Tilde AX1 plus B. It will tell you the slope and the y-intercept. It will also give you your R squared, which is closely related to R. All you have to do is square R. So it will also tell you what R squared is, how good that relationship is. So you really don't have to know too much. You just have to know what R is, what it tells you. You have to know how to make that relationship. And tomorrow we're going to look at whether these cause and effect things are actually related. Okay, so age of Miss America, murder by steam and hot objects, might not be related to each other.